Hello everyone, welcome to my YouTube channel wherever you are watching from, and today I want to show you how to use Euler's method to solve differential equation. We shall go direct into the example. Given dy over dx is equal to 3x squared plus 1 with y of 1 is equal to 2. Estimate y of 2 by Euler's method given that h is equal to 0.5. So this is the type of a differential equation, and we need to use Euler's method to solve this differential equation according to this question. We shall go to the solution. Now, from Euler's method, we know that Euler's formula is given by y sub n plus 1 is equals to y n plus h f into x n comma y sub n. This h is our interval, and this sub n, this is y sub n, and this is y sub n plus 1 that we need to calculate. Before we substitute into this formula, we need to highlight, first of all, the variables provided from the question for easy substitution. We set n to be 0. This means that y naught, y sub n when n is 0 is equals to, according to our question here, y, we shall take this at y naught, which is equals to 2. This means that our x naught shall be equal to 1. Then h is equals to 0.5 as from the equation here, and our function f of x n comma y of n is equals to 3x squared n plus 1. As from the equation, this will be our function f of x comma n, so it will be 3x squared sub n plus 1. So after highlighting the variables provided in the equation, then we can now substitute into the formula. When n is equal to 0, the Euler's formula will be y of 0 plus 1 is equals to y of 0 plus h of f into x of 0 comma y of 0. And from this one, the question is asking to find y of 2. This means that we find the value of y when x is 2 using the interval of 0.5. So we are starting when x is 1, then we add again when x is 1.5, then when x is 2.0. This means that y of 1 shall be equal to y naught. Y naught is 2 plus h, which is 0.5, into our function f. Now we substitute x naught and we substitute y naught to our function here. So in our function here, you see we don't have y. We shall only substitute for x. So this means 3 into x naught squared, because the value of n is 0. So it is 1 squared, because the value of x naught is 1 squared plus 1. Then we close the bracket. For this case, we are finding y1. This means that y1 is the same as y of 1 plus 0.5 is equals to, using the calculator, we have 2 plus 0.5 into 3 multiplied by 1 squared, add 1, then you close the bracket, you'll get 4. So here we have our y of 1.5 is equals to 4. The next step is to find y when n is equals to 1. This means that y of 1 plus 1 is equals to y of 1 plus hf into x1 comma y1, substituting to this Euler's formula here. So n is 1. So we are finding y of 2, which is the same as y of 2.0. We are taking it as 1.5, y is 1.5. Then we are having plus 0.5, the interval. The next x will be 0.5. Here will be plus 0.5 into. We now substitute the value of x1 and y1 into our function, and this is our function here. So x1 is 1.5 multiplied by, this means that it's 1.5 squared multiplied by 3 plus 1. We don't have y function in our function here. So this means that y of 2 is equals to, this is equals to 4 here, plus 2.0 is equals to 4, the value of y1, plus 0.5 into the function this one. So this means that y of 2 is equals to 4 plus 0.5 into 1.5 squared multiplied by 3 plus 1, close the bracket. So y of 2 is given by, so using the calculator, 4 plus 0.5, open the bracket, 3 multiplied by 1.5 squared plus 1, close the bracket. You will get 7.875, and this will be the value of y of 2. This will be our final answer. Now, to summarize this Euler's method, we can say that drawing a table, this is n, this is x, and this is y. When n is 0, this means this is x naught, and x naught here is 1. And then y naught will be 2. Now, when n is 1, we shall have our x1 and y1. So x1 is 1.5 here. This is x1. Then y1 will be 4. And when n is 2, we shall have our x2 as 2.0. Then we shall have y2 as 7.875. Thank you for watching. Remember to subscribe for more understanding.